Hey everyone, welcome back. Today we're cracking open the rulebook for one of chemistry's coolest tools, electrolysis. Now it sounds super complex, I know, but you're about to see it's all based on a couple of really simple, elegant rules figured out by the one and only Michael Faraday. All right, let's jump right in.
So think about this for a sec. You know how a battery works, right? It takes chemical energy that's just sitting there and turns it into electricity to power your stuff. But what if you could do the exact opposite? What if you could plug something in and use electricity to force a chemical change to happen?
Well, that's not just some weird thought experiment. It's totally real. And it happens inside a gadget called an electrolytic cell. You can think of this thing as the engine, the powerhouse that makes this whole reverse battery idea actually work.
So what is it really? An electrolytic cell is just a device that uses electrical juice to kickstart a chemical reaction that, well, isn't going to happen by itself. So instead of a battery where you get energy out, we're actively pumping energy in to create something totally new. And how it works is surprisingly simple. First, you hit it with an electric current. That gets these little charged particles, called ions, moving around in some kind of liquid. As these ions swim over to the positive and negative terminals, the electrodes, that electricity basically forces them into a chemical reaction, making brand new substances. It's pretty neat.
Okay, so how do we actually control what's happening? This is where Michael Faraday comes in with his first law. And honestly, we can boil it down to a super simple idea. More in, more out.
Yep, it is literally that simple. If you're trying to plate a fork with silver and you want a thicker coat, guess what? You just pump more electricity through the system. Want to produce more of a certain gas? Use more electricity. It's a direct, predictable cause and effect relationship. And here it is in all its formal scientific glory. The mass of a substance is directly proportional to the quantity of electricity. Don't let the fancy words fool you, though. This was a huge deal. This discovery turned chemistry from this kind of mysterious art into a quantifiable science. It meant you could stop just watching things happen and start predicting exactly how much was going to happen. It was a game changer. And check this out. This table makes it crystal clear. You put in 100 units of electricity, you get half a gram of product. Double the electricity to 200, and boom, you get double the product, 1 full gram. Double it again to 400, you get 2 grams. See, it's a perfect, beautiful, linear relationship. No guesswork involved. Okay, but what happens if we swap out the materials? This is where it gets even more interesting and brings us to Faraday's second law. The way I like to think about it is that different materials have different electrical prices.
So, let's run a little experiment. Imagine you've got two different setups. You run the exact same amount of electricity through both. One is making silver, the other is making copper. You'd think you'd get the same weight of metal from both, right? Well, you don't. You get a different amount of silver than you do copper.
So, what gives? The amount of electricity is identical, but you get totally different outcomes. Why? What's the hidden factor we're not seeing here? And the secret? The thing that explains this whole puzzle is Faraday's second law. It turns out the amount of stuff you make isn't just about the electricity. It's also proportional to a property called the chemical equivalent weight of that substance. That's the key.
Okay, chemical equivalent weight sounds a little intimidating, I know. But just go back to our price analogy. Think of it as the unique electrical cost for each material. This cost is based on two things: how heavy the atoms of the element are and how many electrons they need for the reaction. So silver has one price, and copper has a different price, because their atoms have different weights and different electrical needs.
So let's put it all together now. When you take these two laws, Faraday's first and second, you get a complete, powerful, and honestly, beautiful rulebook for controlling chemistry with electricity. So here's the bottom line. The first law is all about quantity. It tells you how much stuff you're going to make based on the electricity you use. The second law is all about identity. It tells you how much of a specific material, like copper or silver, you'll get for that electricity. Put them together, and suddenly you have this incredible, precise, and predictable control over chemical reactions. I mean, think about the real-world stuff this powers. Purifying metals for our electronics, electroplating jewelry to make it shine, creating massive amounts of industrial chemicals. All of it relies on these fundamental rules. So the rulebook is yours now. You have the blueprint for creating things with electricity. The real question is, what would you build with that?